Our next speaker is Peter Verraedt from KU Leuven, and his talk is entitled Iron, a Go-based iRODS client and library and a bridge between iRODS and the ownCloud desktop client.
Okay, thank you for the introduction. So I will introduce another client for iRODS, but then first I have to start with the why. So why did we do this? Well, the primary goal was to develop a new stable library for Go applications, because there are existing interesting Go applications as an SFTP server, and we want to plug in iRODS as a backend. So that was the first goal. The second goal was to abstract already a bit of the iRODS API calls into what I call standard Go interfaces, standard ways to work with objects in Go, which means that there would be functions to open a data object as an IO reader interface in Go. Have some functionality already to reopen a file so that you have two streams and you can do parallel stuff and so on. Also, what I wanted to add was to have a richer way to query the catalog. So to have a similar language to play with, just as PRC has to interrogate the catalog. So this library, this was the first goal. Second goal, or this evolved to a full-fledged CLI client. And it's written in Go, so it's portable, it runs on any system. It has no dependencies whatsoever. And a researcher can use it everywhere. It can run on HPC login nodes as well, on laptops, and even on Windows operating system without having to install VSL. And there are two slight additions to that. We aimed to integrate ODC authentication together with the PAM interactive flow in the client to make life easy. And also we looked at optimizing data transfers so that things happen in parallel by default. So what's Iron in a nutshell? So it's pure Go. It talks directly to the iRODS server using the XML protocol, but it also supports, if you want, the native binary protocol, but that's considered a beta feature. So by default, it uses XML and that's stable. So it's two things in one. So it's either a library, let's say a package you can integrate in other Go projects, or a command line client I will show you in a minute. It has some enhanced functionalities. It has an enhanced walk function, which means you can traverse a collection and all its children, and at the same time look at the metadata and the permissions of each object and collection, and you can do something with it then. And also the transfer functionality is embedded, so by default it can parallelize transfers, it can parallelize upload or download files, multiple files in parallel, as well as split large files into different chunks that then are uploaded or downloaded in parallel. It's a single binary. You can run it everywhere, Linux, macOS, Windows systems, native or VSL, you can choose. And it's open source and the source code is on GitHub, so you can contribute if you want to. So now I will talk a bit about the command line client. So for authentication, we chose to support two modes. So the first mode is just the I commands way of working. So you prepare your iRODS environment file as usual, and then there is a command iron add, which mimics init without having to install init, and does the same thing. The second mode is aimed at our users. It's for installations which have the PAM interactive flow by default. And then you only need 3 parameters to connect to a server, namely your username, the zone name, and the domain name of the server you want to connect to. You run that command, and then it writes the iRODS environment file by default with TLS encryption enabled. And then last optimization is when the PAM interactive flow wants the user to connect to a certain URL to log in, actually, it will automatically help the user and open a browser window if it can. And an example is shown on the bottom of a grant flow you have to do in the browser then. So This is a short demo of authentication. So I'm now authenticating against an IDP. So you get a URL. If you run the browser flow, in the end, you are authenticated in iRODS and you see who you are. And if you then later, let's say after a week, want to authenticate again, you just simply have to do iron-add because your iRODS environment file is already in place. And since we do ORDC authentication underneath, there is also a refresh token stored on disk, which then is used to extend your session for another week. And this can then be repeated for half a year for users. So they don't have to re-log in using the login form. Then the command line client, the usage of it, it has familiar operations. You can list files, copy files, and so on. You can compute checksums. It's the UGM2026 checksum, which is shown. You can change permissions and metadata and so on. You also have optimized upload and download operations to transfer either a file or a whole collection, which is then happens in parallel. And also by default, files that are already transferred before are skipped automatically based on modification timestamps and sizes, or on checksums if you want to. So it's a portable alternative for iRSync, which also works natively on Windows. And a killer feature for Iron is that it has shell completion for iRODS objects, and you will see in a minute. It works in Bash as well in PowerShell, but for users that didn't configure the shell completion, because you possibly have to do a thing for that, there's also an embedded shell. If you run iron shell, you will get an embedded shell where you can execute all commands, and there you visually see the tab completion happening. And also the demo will show it in a minute. And lastly, for RODS admins, there is an admin flag. If you provide that, for example, to the shell, all operations will happen with privileges, so you can see any files, you can modify any files you want to very easily. And it's just a matter of providing that flag and you're set. So this is a demo. So the first mode is directly from a terminal. So you can change directories just as in iCommands. You see the directory where you are. You can list files, make collections, upload a single file, or upload the whole directory, and you see a nice progress bar, and it happens. Don't look at the speed because it was recorded on the plane. If you rerun upload, nothing happened, so because everything was up to date. You can see a tree, you can inspect files, you can compute checksums, you can add metadata, list metadata, and so on. You can list files with the metadata. You have glob search functionality, and you can stream files. You can get a file, take the 3 first lines of a file, or save a stream to a file. And then last example was just downloading folder. So maybe it went fast. I will put these videos also in the repository. So this was the first mode. So if you have an existing shell, if you are on a Windows computer and you double click on the Iron application, the embedded shell will show up, and there you have the visual tab completion. And this is the second demo. So I started from the shell, but you can double click on the application as well. And then you see you're in an iRODS directory. You can do the same commands as before, but now you see these blue boxes with tab completion happening. So you see a subtree, you can start a single file, also tab completed, list metadata. And then, of course, if you want to transfer data, you have to change the local path now, not the iRODS path. So you have local commands to change the path or make a local directory, and then you can download into a local directory. Okay, that also went fast, but you can also re-see the demo. So that was about the CLI. This is now the usage as the library. So then I have to show codes. And for example, this is a code snippet which walks, and on the bottom you see walks on a collection and all its children. And for each element, it calls this function above. and you can request path information, but also access information and metadata information in advance. And what is the enhanced thing here is that WAC underneath tries to do as little as queries as possible, so it even groups collections together to get information about all children at once. But that's all hidden. Second example is the enhanced queries. So this looks like a Python query, so you can select columns, some conditions, and loop over results. And people familiar with Go code will see that it mimics other clients that interrogate other databases. So where do we use it as a library? So we use iRON internally to provision users and groups to iRODS from other sources. We also expose iRODS over SFTP. So the SFTP part is already available in Go. We have some duct tape code that calls iRON underneath. We also, for example, have a custom SFTP ingestion service, which is used for untrusted devices to upload data. So what we do is we hand out usernames and passwords to, for example, camera devices, and those cameras connect to this SFTP service, and they can only write files. They cannot see any data they previously uploaded, and they certainly cannot read anything they just have uploaded. So you can use this to give access, write access to untrusted devices. Okay, so that was the iRON library. And the last part of the talk, I want to discuss how we use it to provide desktop syncing tools to researchers. So what was the problem we wanted to solve is researchers are already familiar with things like OneDrive and Dropbox. They just have a local copy of some files and everything happens automatically. And we wanted to have the same experience for iRODS. And for some use cases, this works fine. So we looked at some possibilities already available, and ownCloud and nextCloud are two solutions you can self-host to expose a file system. And we also looked at the work that CERN did already. So they developed a new web component for these clients, especially for ownCloud, so that the desktop client of ownCloud connects to that server implementation to do the actual syncing. Why they chose ownCloud and not nextCloud? Well, one of the reasons is that ownCloud supports OIDC device cloud flow authentication by default. And this is what we want to use. If you are in an environment with usernames and passwords, nextCloud would do as well, but lacks support of renewing tokens. That's why we chose also ownCloud. So what's our setup? Our setup is to have a new this CERN development as a server implementation, and we just plug in iRODS as a backend for that server implementation. So the ownCloud desktop client remains the same. So it means you have all functionality available there. You have virtual files that appear to be on disk, but actually are remote and only are fetched when you open them. You have activity views to see what happens. You have conflict handling if a colleague modified the same file at the same time. So what is Reva? So Reva is what CERN developed. It's actually, they implemented defined the whole framework, which is called CS3, which is the cloud storage services for collaboration. What it actually means is that they have taken the protocol that WebDAV uses for syncing. So it's WebDAV underneath, but there are some additional added layers on top. And they also have protocols for third-party copy mechanisms. So the idea is to have a peer-to-peer Globus kind of solution. But we don't look into that. We just look into the server implementation. It's run in production for their CERN-box, for example, and we use it then for iRODS. So the only thing we needed to do was plug iRODS in as a backend to this server. So you get this scheme. And so you have the ownCloud desktop client, just the default ownCloud client I will show you in a minute. Then you have Reva server implementation of CERN with a bit of custom code, which calls then the next layer, which is iRODS FS. It's a virtual file system represented in Go, which is also open source. And then underneath on the bottom, there is iron. You see also an arrow to open search, and that's because of internal things in this protocol. You need e-tags to identify collections and data objects that have changed. And for collections, it means a version of all its children together. And that's why it's needed. So this is a demo, ownCloud desktop client. You fill in URL, you get redirected to our authentication. You can select a certain folder you want to sync and not too big. And then in the end, you have this nice screen with a folder and cloud icons. So where we are nowadays, well, the CLI I showed you earlier is rolled out at our institutes. Local ITs are also very happy with it. The ownCloud desktop sync client is in pilot phase, but will be rolled out soon. And there are some next steps, among others. We want to add a GUI for people that are even scared of this nice terminal client. And then I want to thank our team as well.
All right. Great. Do we have any questions? We got one right here.
Hi, very nice tools and very nice talk. I have a question on the ownCloud, I think so. For access to what kind of data do you deploy? It's like, so you said it's for limited amounts and in certain situation, like, so where it's in the pilot at least, where it's used in practice to access to what kind of data?
So it's aimed at users that are now having their project's research data already in OneDrive, for example. So they're used to have these flows. Typical Windows users that click on an image and so on. So we just have an alternative now on our iRODS storage. It's aimed at those people. And the only reason I wanted to have small projects is because you don't want to keep the whole tree of millions of objects locally. So that's why it should be a bit manageable.
So if I understand correctly, it's trying to move people that use like Dropbox or OneDrive to use the central storage or whatever system you have and get data from
Yeah,
there.
exactly.
Input data. Thank you.
All right, one more question maybe? Anyone? All right.
Hi. Yes, nice presentation. Thanks. One question about the user. So how is handled the account of user from the ownCloud part to the iRODS part? Is there some synchronization of how this works?
So ownCloud as a separate is integrated with OEDC, so it just talks directly to the IDP to get credentials. And then you get the username of it, and then you connect to iRODS with an iRODS admin account and a proxy user. So that's how it's handled in the back. But it's the same users exist in both systems, so that's no issue.
So you already ensure that the same user exists in both?
Yes.
Okay.
But you could eventually create users on demand in iRODS if you want to.
Okay. But then you now are using impersonation, basically. The admin account impersonate the user when connect.
Yes.
Okay.
Because it's not easy to get a token from Reva. In principle, there is an OEDC token, access token, which is passed, which we could also use to connect to iRODS really as the user, but that was too hard. So it's impersonating instead. Yeah.
Thanks.
All right. Thank you.